we're going to do the exponent parts first. And then we're going to do the logs, because logs are just inverses of exponents. So if we just review the exponents, where the domains, where the ranges are, where their intercept points are, what's unique about them, it'll help us when we go to take the inverse of these things and create your logs. So first off, we're just going to talk basic exponential curves. The reason we start really basic is because we talk about your bases and then just like get into sketching part. Now, we normally don't use a table for these. I'm going to use a table for the first two, just so that you can see what's happening to them and where their common points are. But then what we do is we just sketch. Where in Algebra 2, you had to make sure you had each point there, and you realize in precalc we're just sketching. So by the time we finish these two, we'll just have a basic sketch of a curve. So what this is asking is this. This is my base. This is my exponent. Okay, normally our exponent is not in our when we raise to the power. Usually it's not up there. But that's what makes this an exponential equation. We're going to look at things that grow exponentially, that decay exponentially. We're going to look at those kind of things. So right off the bat, we're just going to start real simple. We're going to put this in your calculator, and we're going to take a look at what this does. Just a basic graph, a zoom 6 basic graph. There's your caret. You're going to raise to the x, and you're just going to graph it. Now, you can see that, again, the same thing we saw with your rationals. Your calculator doesn't always do it justice. It looks like it stops here. But in fact, it keeps on going and going and going and rides along that x-axis. That x-axis becomes a natural asymptote. It doesn't show it. It looks like it stops, but if you look at your table, you'll see the values get smaller and smaller.
The calculator says invalid EIM.
When you raise it to the x, do a zoom 6. Oh, you're plastering. They put, if your plots are on, those dark little things that say plot, just go up there, click on it, and it lightens it, takes it off. Okay, so we're looking at something that looks like this. And again, you can go into your table, and you can take a look at your values. You could see as you get into the negatives, see these numbers get smaller and smaller and smaller. They get closer and closer to your x-axis, but they'll never touch it. So we're looking at certain points here. And what does anybody remember what a negative exponent does? When I say 2 to the negative 1, it turns out to a half. It takes this and takes its reciprocal to the positive. Good. So you can fill these guys in. And the most important one we're going to look at is when it's a 0. And to the negative 1, 1/4, 1/8, 1/16. Notice that they're not negative. They're not negative values. But our values get closer and closer and closer to your x-axis. Now when we graph this, again, we're basically going to do a little sketch. We don't graph by the points, but I just wanted you to see the points because we're going to compare it to the 5. And your graph is just going to go like this. Okay. What's the domain for this graph? Good. All real numbers. What's the range?
0 to infinity.
Now, can we ever use 0?
No.
No. Good. Is there any value for that you could put in to give you 0? Nope, because anything to the 0 power is 1. That's going to become your asymptote. This guy right here becomes an asymptote when y equals 0. So that you're going to see your function ride right alongside of it, but never touch it. Now, we can change the base on yours. We can absolutely change your base. But if we change your base, And your intercept point, I just erased it, but your intercept point for this guy was right here. Your y-intercept. We're going to keep track of your y-intercept right now as well. Now, when you change the base for this, not a lot happens except the numbers are either larger or smaller, whichever side you're on. This guy here is still going to be a 1 because anything to the 0 power is a 1. And these guys, of course, are going to get bigger. And I think this is 625. Again, the negative takes its reciprocal. And if you do this, you can see these numbers getting smaller and smaller and smaller. But there's no negatives. So what happens in this one is it just gets a little bit closer here, crosses the 1, and a little bit closer here. Because those numbers get really high. But if they basically have the same type of setup. Again, this domain says all real numbers. The range, exactly the same. The asymptote, exactly the same. The y-intercept, exactly the same. The only thing the base does on this is just bring it a little bit closer to the, if it's greater than that, if it's greater than, it brings it a little closer to your axis or a little farther away from it, depending on what your base is. But they're all going to have the same basic type curve. If I did a reflection here, if I take my transformation rules and take the negative of x, the negative of x says from positive to negative, reflected here, it's just going to have a reflection. Okay, it's going to follow your same rules that we always use. And when we graph these transformations, we're going to graph them right off your graphs, right off of these guys. So that you see that those are basically the same, we're just going to define some basic characteristics. Oh no. We're doing exactly what we just did. It's a little redundant, but I wanted you to see whether we did a 2 or 5 or 100. They're all going to look the same. So basically, your core graph, this was your 2 to the x, this was your 5 to the x, looked exactly the same. So our sketch is going to look like this. We have basic characteristics. Your domain, your range, your y-intercept, those will stay the same. When our value of, if our base is positive of greater than 1 or our exponent is positive, this gives us an increasing function. This increases, y increases as x increases. So it's increasing throughout my domain. And what's your asymptote for this that guides your end behavior? 0. Y equals 0. Good. And this, we call this a continuous function. We're back to being continuous here. We put our pencil down and we don't pick it back up until we're done. Okay. So these are your basic characteristics of your exponential curves. We said if this is going from a positive to a negative, it's just going to go like this. But the characteristics are going to stay the same. All real numbers, 0 to infinity. My y-intercept reflects on itself. But now, this happens to be a decreasing throughout my domain. My asymptote didn't change. So whether I'm doing an increasing curve or a decreasing curve, I'm going to have the same attributes. So I kind of gave you the 2 and the 5 just to show you. I can't really give you too many bases. 3 we use 3 a lot, we use 4. Once we get into the higher bases, the numbers are way so high that you wouldn't want to really be doing those. But the curves will follow the same patterns. Make sense? Yeah? Okay. Some of this review coming back to you. Okay, now your transformations They work just like the rest of your transformations. We do transformations on all your types of functions. And we do it on your logs as well. Now, we said before, always start with your core graph. Start with your basic core graph. Do your transformations off of your graphs, not off your calculators. So my basic core graph says this. I'm passing through the 0, 1. My domain is all real numbers. My range is from 0 to infinity. And my asymptote is y equals 0. Anything next to the x causes a horizontal shift the opposite way. Remember when we did these? And then we put it next to the x? Same thing. This did a horizontal shift to the right 5. That's going to do a horizontal shift to the right 5. So we're going to say horizontal shift, right, oh sorry, left, left, goes the opposite way, sorry, left, 5 units. Now, because I'm moving horizontally, is my domain going to change? No. Will my range change? If I move horizontally? No. And is my asymptote going to change? No. My intercept is going to change. Where I'm here, I'm going to move 5 units to the left here. So I'm going to move to -5, 1. And my curve is going to go like this. But that's no longer my intercept, right? It's just a point that I moved this by. So I moved 5 units to the left. I keep the same domain, did not change. I keep the same range, did not change. I keep the same asymptote. The one thing that did change now is my y-intercept. Somewhere up here, I'm going to be catching that y-axis somewhere. 32. Sounds good to me. So now, without your calc, I'm going to say y-intercept, x is 0. I'm going to plug this in when x is 0. 2 to the 32, sorry, the 5th is 32. There's my y-intercept, just like Renee just said. Now, I can't ask you for your x-intercept. First of all, it doesn't cross the x yet here. This one doesn't cross the x. But even when we cross the x, if we do a shift, a vertical shift, I can't ask you for your x yet, because to get your exponent, your variable out of the exponent, I need a log statement. So since we're not hitting a log yet, I won't ask you for algebraically for your x-intercept yet. Just your y-intercept. Because your y-intercept, you can certainly put a 0 in for x. When your variable is your exponent, we need a log to bring it down. So again, we have all the pieces that we need. We didn't, a horizontal shift does not change these guys. But it will change your y-intercept. The same ones we did before. We go off of our core graphs. So here's another core graph. Same graph that we just did. Here's another transformation off of your core. We're going to chart your basic core and take a look at it. Write them down right now, because it's going to help you figure out where this is going. And your asymptote is y equals 0. So what transformation does that +5 have on this function?
Vertical shift up 5 units.
Good. A vertical shift up 5 units. Now vertical will change your range. Will your domain be affected? No. Still all real numbers. But the vertical shift, let's take this point 0, 1 and add 5. I'm going to go to 0, 6. Let's take this y equals 0 and add 5. Where's my asymptote now going to go to? y equals 5. And add 5 to your range the same way. My range is going to say 5 to infinity. The one thing I want is that my range matches my asymptote, but has a soft bracket, because that's the point. I cannot use 5, but I'm going to start right there. So my range went up to 5, soft bracket, because my asymptote is sitting right there. And my y-intercept said x equals 0, and we can kind of even count that one, but it says x equals 0, so y equals 2 to the 0, so y equals, anything to the 0 is 1. There's your y-intercept. So much easier if you make a sketch, work off your core graph, shift it left, right, up, down, and just keep track of what you can. If you're going up and down, your range is going to change on a vertical shift, so is your asymptote going to change on a vertical shift. Good so far? So much easier without your calculator. Just use a sketch. Basic sketch. Okay? And this last one we have?
Reflection over the y-axis.
Well, think again. It's not by the x, it's by the y.
I did say the
Yes, but it's not over the y-axis. Here's your basic graph. So here's my basic curve. Let's start with this. Here's my 0, 1. Here's my domain. Here's my range. Here's my asymptote. Now, if it was next to the x, I would take the x from positive to negative, and my reflection would be in my y-axis. But this is not affecting the x, it's affecting the y. So when my y goes from positive to negative, here's my reflection over the x-axis. A reflection in the x-axis. Now, this point is going to reflect down here. Does your domain change?
no.
No? Still all real numbers, right? Oh. I'm like a scatterbrain today. Okay. What about your range? Did your range change?
Yes. It's negative infinity to 0.
Good. It flipped over. We flipped this over, it flipped over. What about your asymptote?
No.
No, your asymptote stayed the same. And we call this the reflection over your x-axis. If the negative was by the x, it would be a reflection in your y-axis. But because it's not affecting the x, it's going to the y, it's a reflection over your x-axis. Good? Basic transformation, basic